Hey everybody, Opie Taylor here, and this lesson is on simplifying radicals. This is part one. So there's a couple ways to simplify radicals, you guys. One way is, this is my favorite way, to get the prime factorization of the number inside. And then the trick is you need two on the inside, two of the same number on the inside that brings one number on the outside. So for example, if I got the square root of 24, you guys remember factor trees, you guys? So if we broke down 24, and I did that over here, 24 is 6 times 4. 6 isn't prime, so it equals 2 times 3. 4 is not prime, that's 2 times 2. So here's the prime factorization down here, all these circled prime numbers. That's the prime factorization, so here they are in order right there. Okay, so get the prime factorization of the number inside, and then you need 2 on the inside that brings 1 on the outside, 2 of a kind on the inside. So I have these two that'll match up, so it'll bring 1 2 on the outside. So 2 2's on the inside brings 1 2 on the outside. And since these don't match up, they stay inside the radical, so you're going to get 2 root 6 would be your answer. Okay, the second way is to factor the inside number using perfect squares. Now, if you're good with your factoring, you guys, this way is faster. It's much faster. But I'm finding most of my Algebra 1 students kind of they struggle with their factors. So the prime factorization works every time. So I like teaching it that way. So for example, the square root of 24 is also equal to 4 times 6, and 4 is a perfect square because the square root of 4 is just plain old 2, so you get 2 root 6. It's quicker that way, but you got to know the perfect squares that go into that number. Okay, so let's go ahead and simplify the expression here. Here's number 1, square root of 32. Okay, 32 I did over here is 8 times 4. 8 breaks down to 2 times 4, and I circled the 2 because that's prime. 4 breaks down to 2 times 2, and I circle those, and then this other 4 is 2 times 2, so it's all those circled 2's. That's the prime factorization. There's 5 of them. Then I need 2 of a kind on the inside that brings 1 out, so this pair right here brings this 2 out. This pair right here brings this 2 out, so I'll go ahead and multiply those, and you get 4 root 2 as your final answer. Okay, if you'd have done it the other way, you guys, if you can recognize that 32 is also equal to, whoops, 16 times 2. I forgot to put a little times right there. So 16 times 2 right there, there's 32. And then you just, come on now. And then you just square root 16, which is 4, and then you get root 2. Okay, it's quicker that way, but you got to know your factors quite well, and like I said, a lot of my students don't. Okay, square root of 9x to the third. Okay, I'm going to write 9x is 9 is 3 times 3, and there's x to the third right there. Then I start taking 2 on the inside, brings 1 on the outside. So 2 3's on the inside brings 1 3 out, and then 2x's on the inside brings 1x out, and I'm left with this leftover x right there. So 3x root x is your answer. Okay, how about this one? Alright, so what you're going to do here is go ahead and combine them under one radical, and then here's 10, 2 times 5, okay, get the prime factorization, then 2 2's on the inside is going to bring 1 2 out, and you have that leftover 5. Okay, how about this one? Alright, so I'm going to combine the 3x with the x. You combine the innies with the innies, and this outie stays outside right there. The 4 stays outside. So there's 3x, and then there's the other x right there. And then these two x's are going to come out as 1x on the outside, and your 3 is left on the inside. Okay, how about this one? Okay, the 3 stays out. I'm going to go ahead and put the inside numbers together. Break down 8, which is, we found out, is 2 times 2 times 2. And then I'll put these two x's together, and this is y times y. So here we go. So 2 times 2 times 2 times x. There's my y squared, and there's my 2x right there. Okay, and then if you can just see, I can pull a pair of 2's out. I can pull a pair of x's out, and pull a pair of y's out. And this 2 right here matches up with this 2 over here. So everything comes out in pairs. There's no radical left because there's nothing left inside the radical. So then go ahead and multiply those guys out, and you get 12xy. All right, okay, so now another thing about Algebra 1 is you can't have a radical in the denominator, okay? So when you have a fraction like this, you go ahead and separate the top and the bottom up into the radical. Nicely, the square root of 100 was just equal to 10, so this just became square root of 13 over 10. Okay, But on this one here, you guys, I got to get rid of this radical. Math doesn't let us keep radicals in the denominator. So I'm going to multiply this fraction by 1, but my 1 is going to be root 11 over root 11. That way I'll have two 11s on the inside downstairs. That brings one 11 on the outside. Okay, so I'm going to have 7 root 11 on top, and then two 11s on the inside is going to bring one of them on the outside. So there's my answer right there. And a real common error, students want to cancel these 11s right here. I can't, because this is an innie and this is an outie. They either got to both be outies or both be innies to cancel, and I can't when one's an innie and one's an outie. So that's the answer right there, 7 root 11 over 11. Okay, how about this one? Okay, I'm going to multiply again, this one but times 1, but my 1 is going to be the square root of 3x over 3x. That way I'll have two 3's on the inside and two x's on the inside that come out. Okay, so you can have the radical in the top, you just can't have the radical in the bottom. So here's my 2 times my 3x, and then here's my 3 times 3 is right here, and then here's my x times x. So I have two 3's on the inside downstairs, two x's on the inside downstairs, and there's my answer. Okay. Okay, on this one, I'm going to go ahead and separate those. The 8, remember, is 2 times 2 times 2. And there's my 3x to the third. Okay, now I'm going to need two of a kind. I'm going to need another 3 to pair up, you guys. These pair of x's are going to pair up, but I'm going to need one more x to pair up. So my 1 in this case is going to be 3 to get rid of the 3 and the x to get rid of that additional x that's downstairs. All right, so what I have on top is all of those, and that's what I have on bottom. I rearranged them. Okay, so now on top, a pair of 2's are going to come out, and that's it on top. On bottom, a pair of 3's are going to come out, a pair of x's are going to come out, another pair of x's are going to come out. So you're going to get, there we go, and I get 2 root 6x over 3x squared. All right, and I'm going to stop it right there. I think this is a good stopping point. I'm going to split this section 8.4 into two sections. So take a look at part 2 when you're done completing this one right here.